in chemistry in relationship to what?
Table.
Periodic table. So called because of what? Why do we call it the periodic table? Because of the periods. Why do we call them periods? Circular logic, no. Because characteristics of the elements listed in the periodic table recur periodically. So anything that recurs at a regular interval we call periodic. You come to school periodically. Every morning. 7:30. You come to physics periodically. And with love in your heart, I know. So, when we take a pendulum, which we're going to construct here, we have periodic motion. If we take a spring and attach to it a mass, we have periodic motion. So let's not do the heaviest thing possible. Let's do something slightly lighter. Yeah, we don't want to break anything.
Especially that, you know, that like 8,000 milliliters.
Right, that would be expensive. Okay, so here we go. I've got a spring, I've got a mass attached to it. What's going to happen if I let go?
This is fun. I want to do this.
Okay, it's bungee jumping for square masses. It's hypnotic. I strongly recommend that if any of you go off to college and major in physics or engineering, find some other geeks, take your apartment or your dorm room, hang it all over with springs. You'd love it. You'll love it. You'll enjoy it. It'll enrich your life. Okay, this is periodic motion. Why is this periodic motion?
The same.
Regular.
There's a regular interval in which what happens? Goes, whoops, we're off.
It's swinging.
It shouldn't be swinging. It goes down, it returns. Down, up, down, down. Okay, ad infinitum. That's periodic motion. Okay, so we're going to talk about springs. More springs. So this gets back to the idea of elastic potential energy, and we talked about deformation of the material. You know that the elastic potential energy in that spring is stored, because of the nature of the material. When we deform the material, then you were hoping for something more dramatic.
Yeah.
When we deform the material, we then have it return to its original shape, because it's got stored energy in it. We call that undeformed position equilibrium. So for a mass and spring system, that's your equilibrium, where it's not deformed right now, except it's just sort of in its native state. It's resting. For the spring by itself, that's the undeformed position. But for the spring mass system, it's a little bit different. It's the point at which it's just resting. And we talk again about X. I'm going to line this up so we can see the spring. X is that amount of deformation, and we talked about X being equal to 0 at the equilibrium position. Now, there are two different kinds of springs.